Hi, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting topic in Unit 3. We are going to see Booth algorithm. We have seen signed multiplication and unsigned multiplication in previous videos. And this video is about Booth algorithm, right? So we are going to see why is that we go for Booth algorithm? What is the greatest advantage of Booth algorithm? Right? What is the important change that has to be taken when compared to signed multiplication and unsigned multiplication? That is what we're going to see, right? So Booth algorithm is very important concept in this particular unit, right? So we'll start with Booth algorithm. Now the signed multiplication, it has a different process for, right, positive multiplier and negative multiplier, correct? For positive multiplier, it just looks like normal multiplication and it extends the sign, right? And then it performs normal addition. But for negative multiplier, what it does, it takes 2's complement of it, right? And it performs the normal multiplication. And if there is 1 in the MSB of the multiplicand, it takes 2's complement of the multiplicand, correct? Right. So it is different. It is completely different, correct? So in order to do it in a uniform way, right, there is another technique which is called as Booth algorithm, right? And that is what we are going to see now, right? So what is the main advantage of Booth algorithm, right? In Booth algorithm, it does not have two different process, right? That is for positive multiplicand and for negative multiplicand, you don't want to worry. For positive multiplier and negative multiplier, you don't want to worry, right? Same process for everything, okay? But what is Booth algorithm first? Why is that we go for it, right? It can speed up the multiplication process, okay? The first thing is it can gain some advantage, okay? It reduces the number of operations in the normal multiplication. Compared to the normal multiplication, it reduces the number of operations, right? And another advantage it has, what is that? Right, for both positive and negative multiplicand, the same process. Got it? Right, so far clear? Right, now what is the first step in Booth algorithm? In Booth algorithm, the first step is you have to change the multiplicand, right? You have to change the multiplicand. How is that I have to change? Since it is a signed multiplication, correct? Since it is a signed multiplication, we have to have a multiplicand, whether it is plus or minus. Okay, for example, if you take this one, 1, 0, 1, 0. If this is your multiplicand, right? You have to change this multiplicand, right? So how is that I change, right? You have to change how, like, consider, listen very carefully, this is very important, okay? This is Booth algorithm, okay? Now listen. Consider an imaginary zero for all the problem. Consider an imaginary zero, right? And there is certain rules and regulations here, right? So from, if it is an imaginary zero, here the transition is from 0 to 0, right? If it is 0 to 0, then it is 0, right? And if it is 0 to 1, it is minus 1. And if it is 1 to 0, it is plus 1. And if it is 0 to 1, it is minus 1 again, right? Now listen, this is how you have to change, right? That is from 0 to 0. These are some rules and regulation. You can see this side, I'll explain that, okay? So if it is 0 to 0, right, it is 0, right? If it is 0 to 1, it is minus 1. If it is 1 to 0, it is plus 1. 0 to 1, it is minus 1. So now instead of using this multiplicand, right, we have to use this multiplicand, right, and do the normal multiplication. That is called as Booth algorithm, right? You clear? So now how is that I can understand this transmission, right? Like you can see here, as I said, for 0 to 0, if it changes from 0 to 0, then it is 0. M is nothing but multiplicand, right? 0 of multiplicand, okay? Right. That is, and similarly, if it is 1 to 1 transition, then it is 0, right? And if it is 1 to 0 1 to 1 transition, then it is plus 1 of M, right? And if it is 0 to 1, then it is minus 1 of M. Like that, I have done this one. You got it? This is the table, very important table to understand Booth algorithm. Okay? Now listen, this is a very big multiplier. Okay? Now, Booth algorithm change this multiplier into this one. Okay? How it has changed? Now listen very carefully. Consider imaginary zero, right? If an imaginary zero from 0 to 0, it is 0, right? So 0 to 0, 0, correct? And then again 0 to 0, it is 0, right? And 0 to 1, it is minus 1, right? From 0 to 1, it is minus from C from the left hand side, right? And now 1 to 1, it's again 0, right? So 0. And 1 to 0, it is positive 1, right? And 0 to 1, it is negative 1. And 1 to 0, positive 1. 0 to 1, it's negative 1. 1 to 1, 0, right? And again 1 to 1, it's 0, right? And 1 to 0, it is positive 1. And 0 to 0, 0, right? And 0 to 1, right? 0 to 1, again minus 1. And 1 to 1, 0, right? And again 1 to 0, positive 1. And 0 to 1, negative 1. And 1 to 0, positive 1. 0 to 0, 0. You understand now how the multiplier is changed? Okay, all you have to do is you got to understand this table, right? So that you can change the multiplier. Okay, right? And after that, you will do the normal multiplication, right? Now, listen very carefully, right? Right, I'll explain this flow chart a little later. Okay, after seeing the both algorithm, I'll explain this. Okay, now listen, right? So this is, say for example, you have given this number, right? This number, and this is the multiplier. Okay, now whatever multiplication you do, if you do normal multiplication or signed multiplication or both algorithms, the answer has to be same, right? The answer has to be the correct one, correct? Right. So even if you do normal multiplication and both algorithm, you have to get the same answer, correct? So how will I prove that? Now I'll do the normal multiplication here. Okay. Don't worry about this plus sign. Just I am using the same multiplier. This is the normal multiplication, correct? Normal multiplication. I'm not extending sign. I'm not doing anything here. Okay. So normal multiplication, you can see this is the multiplicand and this is the multiplier, right? So here what I'm going to do, I'm just going to use this first, this is the multiplier, 0. So 1, 2, 3, 4, 5, 6, 7. So everything will be 0 here, right? And 1. If it is 1, you have to write the multiplier. Like you have to shift this here and you have to do the same, you have to write the same multiplicand, right? 1, 0, 1, 1, 0, 1, 0, right? And again it's 1. So shift again and again you write the multiplicand. And again it's 1, right? So you shift 1 and write the same multiplicand. And again it's 1, so you have to change, shift 1 and multiplicand. And again it's 0, so everything will be 0. And again it's 0, everything will be 0, correct? So now you do the normal addition, right? So 0, 1, 1, it's 10 here, right? So it's 0 and 1 carry here, right? So it's 4 ones, so it is 100, so it's 0 and 10 here, 10 carry, right? And 10 plus 1, 11, 11 plus 1, 100, so it's 0 again, and 10 carry, and 10 carry here. So 10 plus 1, 11, right? 11 plus 1, 100. 100 plus 1, 101. So it's 1 and again it's 10 carry here. So 10 plus 1, right? 11. 11 plus 1, 100. So 0 and then again 10 carry. So be careful with the 10 carries, okay? 10 plus 1, it's 10 carry, right? 10 plus 1, 11. So it's 1 and 1 is carry here. So 1 plus 1 here, 10. So 0 and 1. And this is 1 and everything is 0. Got it? Got it? This is the normal multiplication. Correct? Right. Now what I have to do? I have to change this multiplier for Booth algorithm. This is the Booth algorithm. Correct? This is the Booth algorithm. Now what I have to do? I have to change the multiplier. Right? So now listen very carefully. Right? First I will change the multiplier and we go to the Booth algorithm. Okay, so this is the multiplier, correct? 0, 0, triple, 4, 1 and 0, right? This is the multiplier, correct? Now what I have to do, I have to change this multiplier. What I will do, I will consider an imaginary 0. So imaginary 0, 0 to 0 is 0 and 0 to 1 is minus 1 and 1 to 1 is 0. Right, and again it's 1 to 1, it's 0, and again it's 1 to 1, it's 0, right, and again it's 1 to 0, it is positive 1, right, and 0 to 0 again it's 0. Okay, so what is the value? 0, positive 1, 3 zeros and minus 1 and 0. Got it? I change this multiplier as 0, positive 1, triple 0, negative 1 and 0, right? So this is the multiplier I'm going to do. I'm going to multiply this one, correct? Right? So see here, this is the multiplier. 0, positive 1, triple 0, minus 1 and 0. Got it? That is what we have obtained, right? 0, positive 1, triple 0, minus 1 and 0. 0, positive 1, triple 0, 1, minus 1 and 0. Got it? Right? Now, we're going to do the same multiplier here, right? And understand one particular thing, right? Here, so far in normal multiplication, there is no minus sign, correct? But here we have minus sign, right? If it is positive 1, what you will do? You will write the same multiplier value, correct? You will write the same multiplier value. If it is minus 1, normally what you will do? You have to write the 2's complement of this number, okay? So before going to this Booth algorithm, right, what I'm going to do, I'm going to find out 2's complement of this multiplicand, okay? So now remember 0, 1, 0, 1, 1, 0, 1. This is the multiplicand given, okay? Now I'm going to take 2's complement of it. For take 2's complement, what I have to do? 0, and first want to convert into for 1's complement, right? 0, 0, 1, 0. And I have to add 1 here. So what I'll get? 1, 0, 1, double 0, 1, 1, right? So this is the 2's complement of the multiplicand. And this is the given multiplicand, okay? And remember only one thing here, right? What is that? Right? What I'm going to do here is, if it is positive 1, I'll write the multiplicand, the same value. If it is minus 1, I'll use the 2's complement, write this value, okay? Right? Now, we'll do the Booth algorithm now, right? So, what is Booth algorithm here? Listen, right? So, if you consider this one, 1, 2, 3, 4, 5, 6, 7, right? So, 7 plus 7, 14 bits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, okay? Now, right? I'll just do the same steps here, right? And finally, I will add it here so that you can understand, okay? So here, listen, 0, 1, 0, 1, 1, 0, 1, right? And your multiplier is 0, positive 1, triple 0, minus 1 and 0, correct? Okay? Now, for 0, what I will do? Everything will be 0, right? 1, 2, 3, 4, 5, 6, 7, right? 1, 2, 3, 4, 5, 6, 7, right? But here 7 plus 7, 14 bits is there. For product, you will get 14 bits, right? So for sign extension, what you will do? You will add another 7 bits here, right? So it is 0 here. So I'm adding it zeros. If it is 1, we got to extend 1. If it is 0, you got to extend 0, right? So it's 1, 2, 3, 4, 5, 6, 7. And this is what done it here. Got it? Now it is minus 1. Listen very carefully. If it is minus 1, what I have to do? I should not write this multiplicand. I have to write 2's complement of this multiplicand, right? So what I write 2's complement, right? I have to shift 1 here. So 1, 1, 0, 0, 1, 0, 1. Got it? Right? This value, right? 1, 0, 1, double 0, double 1, right? 1, 0, 1, double 0, double 1. Correct? That is what here done here, right? 1, 0, 1, double 0, 1, 1. Correct? Got it? Right. So now what I have to do? I have to extend the signed bit, right? So it is already extended. Now I have to just add ones here. That's all. Got it? Right? And now what I have to do? This one is over, right? And again 0, right? So everything is 0. So what I will do is 0, 0, 0, 0, 0, 7 zeros, right? 6, 7 zeros, and remaining also 0. That is, I'm extending the sign bit, correct? And again, this one 0. So I extend here 0, 2, 3, 4, 5, 6, 7. And again, I'm putting 0, extending 0, right? And now it's positive 1. Positive 1 means we have to write the multiplicand, correct? So if it is positive 1, it's 1, 0, 1, 1, 0, 1, 0, right? So it is 0, so I'm extending zeros here. And the last one is also 0. So what I will do, I'll just extend 0. 0, 0, 3, 4, 5, 6, 7. Okay. And now what I will do, I'll extend zeros. Got it? This is the same thing which we have done here. Okay. to make you understand, I have executed it. Okay, right? So now you can easily add. This is normal addition, right? You got to add 0. You can see the 0, right? It's 1, right? And it's 1 here and 0 here, 0, and it's 10 here. So 0, 1 carry, right? 1 carry here. So it's 1, and again you can see here. Sorry, it's 10. So I'll just do it again. So it's 0, right? And it's 1, and again it's 1, and it's 0, and it's 0, and it's 10 here. So it's 0, and it's 1 again, right? So I'm putting 1 here, and it's 1 plus 1, 10. So it's 0 and 1 carry, right? So it's 1 plus 1, 10, 10 plus 1, 11. So it's 1, 1 here, and 1 plus 1 is 10. So 0 and 1 here. So it's 1 plus 1, 10, and 1, 11. So it's 1. So it's 1 here. 1 plus 1 is 10. So 0, 1. So it's again 1 plus 1 is 10. So 0, 1. And again it's 1 plus 1 is 10. So 0. And here it's 1 will be coming. But we can eliminate it because only this bits we need. Okay. Right. So this is Booth algorithm. Now you can cross verify this. You cross verify this. What do you get? Right, the same value. You have to get the same values here, right? 000101, correct? 000101. You can see here 000101, right? And 01000, right? 01000, right? And remaining thing is also same, right? So even if you use normal multiplication or Booth algorithm, the concept is same, right? So you understand. Hope you clear with this, okay? Right now, one main thing you have to understand here, right? Before going to the next example, you have to understand one main thing. Sir, why is that we go for Booth algorithm? What is the advantage we get? Okay, if you see, like we manually do it, right? In computers, as I said, what computer will do is it will consider only these operations. It will just leave these zeros because 0 means no operation. Okay, so here if you see, you have 4 ones. Okay. So the computer will execute all this 4 operation, right? Correct? Right. But if you change the multiplier, what will happen here? You'll get only 2 ones. That is 1 positive one and 1 negative one, right? So it reduces the operation here. So you'll just computer will do only this 2 operation, right? For other zeros, it will just shift. Okay. So the operations is reduced, right? It gains the speed of the operation is increased here in Booth algorithm. That is very, very important. Okay. And similarly, for 1's complement or if it is negative multiplier or positive multiplier, you don't want to worry, it's the same process. Okay, how is that I'm saying? You can see this example. Okay, right? I'll just explain it little faster here. Okay, right? So you can see here, we are going to see Booth multiplier with negative multiplier. Right? Last example is we have seen Booth algorithm with positive multiplier. This is positive multiplier, correct? And now we see negative multiplier, right? So if it is negative multiplier, it is also the same process. You don't want to do anything, right? So like what you have to do, this is the multiplier, right? 1, 1, 0, 1, right? So 0, 1, 0, correct? So what I got to do, I got to change this multiplier. What I will change, I will put an imaginary 0, right? If I put imaginary 0, 0 to 0, it is 0, right? And 0 to 1, it is minus 1, correct? And if it is 1 to 0, it is positive 1. Right? And if it is 0 to 1, again it's minus 1, right? And if it is 1 to 1, it is 0, right? So you can see this is the multiplier which is used here. 0, minus 1, positive 1 and minus 1, right? And 0. Got it? Right? And similarly, before executing Booth algorithm, what you have to do? You have to have the multiplicand, the original multiplicand and 2's complement so that it will be easy for you, correct? So this is the normal multiplicand. If I take 2's complement, what will happen? 1, 0, 1, 0, right? If I have to add this one, what I will get? 1, 0, 1, 1. So this is 2's complement, right? So for negative 1, you have to use this value, right? For negative 1, you have to use this value, and for positive 1, you have to use this multiplicand, correct? So that is what we have doing here. So it's 0, so everything will be 0, and for 1, right, it is minus 1, right? So listen, if it is minus 1, what I have to do? I have to use 2's complement of it, right? 2's complement of the multiplicand, right? So you can see 1, 0, 1, 1. You can see 1, 0, 1, 1, okay? And the sign is extended like before, right? And then it is positive 1, so I use this number, right? 0, 1, 1, 0, 1. And the sign is extended. Okay, and similarly this is -1, then I'll use the 2's complement, 1 0 0 1 1, right, and sign is extended. Okay, and the last one is 0. If you add this one, you'll get -78, right? So it will be the same answer like this. If you multiply 13 to 16, you'll get -78, right? And in order to check this, you can take 2's complement of it. You will get the positive 78. So the answer will be correct. Okay, got it? So now you understand what is the concept of Booth algorithm, right? So far we have seen, what we have seen is we have seen Booth algorithm for negative multiplier and as well as positive multiplier, right? And the greatest advantage of Booth algorithm is you can see all these examples. This is positive multiplier, this is positive multiplier, this is negative multiplier, this is negative multiplier, right? And this is positive multiplicand, this is negative multiplicand, this is negative multiplicand, this is positive multiplicand, right? Whatever may be the operation, right, whatever may be the multiplicand multiplier, you don't want to do different steps like the sign multiplication, the normal multiplication, right? All you have to do is you have to change the multiplier like this, right, and you have to do multiplication. It is uniform step for all the multipliers. Okay, that is the greatest advantage of Booth algorithm. Okay, right? So, and now you understand why is that we go for Booth algorithm. Two steps. One is for both negative multiplier and positive multiplier, it will be same, right? Same uniform operation, right? And also, as I said before, it minimizes the operation, right? It reduces the operation. That is, it increases the speed. It gains the speed. The speed of operation is better. Okay. But one thing you have to be very clear. Not all the multipliers, not for all the multipliers, Booth algorithm will be very effective, right? For example, right, if you see this one, this is the good multiplier, right? The Booth algorithm will work very beautifully or very efficiently, right, when there is more number of ones consecutively. If there is more number of ones consecutively, as we saw before, right, instead of 4 operation, it had only 2 operations, correct? And if you see this one, right, you can see here, right, this is the normal multiplication, normal multiplier, right? So if it is normal multiplier, how many number of ones? 1, 2, 3, 4, 5, 6, 7, 8, right? So there will be 8 operations. If I use Booth algorithm, what I will use? 1, 2, 3, 4. Only I will use 4 operations. So this is a very good multiplier, right? Because we have more number of consecutive ones here, right? And there will be an ordinary multiplier also. That is, there will not be more change. That is, even if you use normal multiplier, you will get the same type of operation, right? Only one or two bits will be difference, right? For example, if you see here, if you use normal multiplier 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, instead of 9, if you use Booth algorithm, what you will get? 1, 2, 3, 4, 5, 6, 7. 7 operation is enough. Okay, right? So this is the normal multiplier. This is not very good like this, but it is ordinary. Okay, and there is, even if you use Booth algorithm, there is burst multiplier as well. Like if you see this one, if it is this one, right? If the normal multiplier 1, 2, 3, 4, 5, 6, 7, 8, right? So you will have a normal operation itself, you have 8, right? And if you use Booth algorithm, what will you get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 operations. So this is the burst multiplier, right? So even if you use Booth algorithm, as I said, for a good multiplier, it will reduces the number of operations, okay? And there will be an ordinary operation, some sort of a gain will be there, not much, right? But there will be a burst multiplier. Instead of 16, instead of 8, we will use 16, right? So it is a burst multiplier, okay? So even if you use Booth algorithm, right? So there are chances that there can be a burst multiplier as well, okay? So today what we have seen is we have seen signed multiplication, okay? We have seen signed multiplication for different number of multiplicands, right? For positive multiplicand and negative multiplier and in vice versa, right? We have seen all the executions, okay? Hope you are clear with the concept, right? So this is very important topic in this particular unit, right? Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.